Pythagorean Theorem. So 5, 7 is the Pythagorean Theorem. You don't really need to worry too much about that word theorem for now. That'll come up more like in a high school geometry class, where theorems technically are things that are proved. So like I had said before we started the notes, that there's several ways that this has been proved. Here's pretty much the gist of it, is that I'm going to put a little star by it and say you can find a missing side, or maybe missing side length, of any right triangle using, and here's the actual equation. They always do lowercase letters, so it'll be a squared plus b squared equals c squared. So a squared plus b squared equals c squared, that this technically is the Pythagorean theorem, this a squared plus b squared equals c squared. And there's actually, if you go on, once you take algebra class, or algebra 2 class especially, you'll learn, well, how could you take this equation and change it a little bit to make it work where you can find the side length of any triangle. It doesn't have to be a right triangle. But setting up the triangle is going to be key. Well, one, for now, for this equation, it has to be a right triangle. And a right triangle means one of the angles has to be 90. Perfect. So if you want to draw a little triangle, you can. Where you put A and B and C matter. And really what it is where you put C is what matters. That C has to be on this side here. You guys have learned the name of that side before, I think. The longest side of a right triangle is called the
long side.
The long side. The hypotenuse. Is that new? So, okay. So this side here is the hypotenuse. If it's new, maybe I'll say a couple things underneath it. One, it's going to be the longest. And two, you can tell it's the hypotenuse because it'll always be opposite or across from the 90-degree angle. That whenever you have a triangle where one angle is 90 degrees, the longest side has to be across from that 90-degree angle. It'll have to be. Now for A and B don't really matter as far as which one's the vertical in mine and which one's the horizontal. Just A and B have to be on the other two sides, which they call legs. So maybe we'll kind of like label those two also. But those sides, the legs, those are going to be the short sides. And they touch, or you could say they meet, the 90-degree angle. So A and B could be either one of those two legs. C has to be the hypotenuse in order to get it to work. This a squared plus b squared equals c squared. My plan is the first page of your test in a couple weeks is going to be, I hand it out to you, and one of the questions on it is going to be write down the Pythagorean theorem from memory. So you need to know Pythagorean theorem is a squared plus b squared equals c squared. Make them all lowercase letters. Then when you turn that page in, then you take the rest of the test, and I'll give you the equation to use on the rest of the test. So want to do a couple examples. And maybe I should say one other thing first before I jump into my examples. The book makes this comment. They say, if a squared plus b squared does not equal c squared. So if a squared plus b squared does not equal c squared, so this here means does not equal. So if you wanted to, you could just write out the does not equal. In other words, if one side of the equation isn't equal to the other side of the equation, then it's not a right triangle. The triangle is not a right triangle. That seems like usually I don't see questions like that like in the high school curriculum, but we're doing some of that now that it's going to give you a triangle and say, is it a right triangle? And then if you punch in like the A and the B, and if it equals the C, then you know the angle has to be 90 degrees, one of the angles in the triangle. If it doesn't equal, then you know it's not a right triangle. Now we'll jump and do a couple examples. So I'll say example 1. Here's the one I was looking at before and was all confused. So I was building a shed for my backyard, and I was trying to figure out how long do I need to cut one of my boards in order to get it to work for this roof part. So what I was doing is I was looking at this part here, and I was trying to figure out, well, if I want to have a certain slope to that, how long does it need to be? And if you look at the side of the shed in my yard, that this length here is going to be 8. So that's going to be an 8. And I wanted to have the height of the shed to be 3. So just to make that a little easier to see, I'm going to take and redraw this triangle part right there. And so it's going to be a little bit larger. But I have a triangle, something like this here. I wanted to have that distance of 3 upward being at a 90-degree angle. My bottom edge isn't going to be 8. It's going to be, if 8 is this whole length, it's going to be 4. Nicely done. So my triangle drawing totally stinks, doesn't it? So my 3 and 4 are way different. So I'm going to try to make mine a little closer. If yours is off, it's not really a big deal. So something like that. And I'm trying to figure out how long do I cut that board, how long does that side need to be. So as far as A, B, and C goes, my X, is that going to be A, B, or C? C. And it has to be C because it's the longest, it's across from the 90-degree angle. 3 and 4, do they matter? As far as which one's A?
No.
Nope. So I'm maybe going to make my 3A and my 4B, but you could label it either way. Please, 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 my friends, make your life easier later on, and now in some ways. If you write out the a squared plus b squared equals c squared, then from there now you can plug and chug, and it'll be easier to remember it to come test time if you write it down in the homework. But for a squared, well, a is 3, so I put a 3 in for a. B is 4, so I put a 4 in for b. So I have 3 squared plus 4 squared equals, should we make it x squared? Leave it c squared? Do you have a preference? Go for it. I'll pick to change this to an x. So I have x squared. So now my 3 squared is going to be a 9. My 4 squared is 4 times 4 is 16. That equals x squared. So 9 plus 16 is 25. And a lot of people, they'll go right from this step to this in one. They'll just take their calculator, do 3 squared plus 4 squared equals. And that's legit, you can do that. But 25 equals x squared. How do I find x? I get rid of the squared by doing, not division. Division is the opposite of multiplication. The opposite of, we just did it in the last section. Square root? Apparently I didn't do a great job of it in the last section of my teaching, maybe. But if you're trying to find the side, we need to get rid of the squared by doing square root. And now what happens is like the square root and the square kind of cancel and just leave you an x on this side. And square root of 25 equals 5. Yep, because that's saying what times itself equals 25. So in other words, I'd have to make the length of that board 5 long. Do you want to know a trick that shows up on the ACT pretty much every year? They'll give you one triangle that if you have a triangle with a side length of 3 and a side length of 4, the hypotenuse has to be 5. They call it a 3, 4, 5 triangle. All right, example 2. So example 2. This one here, the difference is going to be we're solving for a leg. And maybe I'll even put like solving for a leg. And you can skip that if you want to, but my thought is if I write it, if you write it, if you're getting partway through the homework and you're like, ooh, how do I do this? You could look back, oh, look at example 2, kind of copy things from there. But I'm going to make it into a story problem. I'm going to say I have a 20-foot ladder, so the little apostrophe just stands for foot, so 20-foot ladder. I'm going to say I locked myself out of my house and I want to climb in my upstairs bedroom window because I can see the windows open, I don't have to break the glass. So I have a 20-foot ladder against the house. And I'm afraid if I lean the ladder up against the house, it's going to break the window. So I want to figure out how high is the ladder going to go? Is it going to break the window or not break the window? I'm going to say the base is 5 foot from the house. How high will the ladder go? Or how high will the ladder reach? Something like that. I've been doing teaching math for a whole bunch of years, and I've seen lots of people, they get to story problems and they just try to do something with the numbers, and they do all kinds of wacky things. Really, the best advice I can give you with these story problems are confusing. A lot of people don't like them. Take and change it into just a triangle. So figure out, how do I draw a triangle for this situation? So triangles are going to be more wide or more tall for something like this? It's going to be pretty tall. If you're looking at, like, you have a house, you're tipping a ladder, like a 20-foot, a pretty tall ladder against it. So I would start just by drawing a triangle, and I'm going to make it look like this. And really, you could even kind of skip that step. It's nice if it's kind of to scale, but if it's not, it's okay. Still get your triangle labeled. But I had two numbers. I had 20 and I had 5. So we could either figure out where do we put the 20 and 5, or you could say what's the unknown and put like an X there or something. So somebody tell me what to put on one side of my triangle. Feel like you can take a stab at it?
Wait, what are we?
Right, so we have a 20-foot, we have a 5-foot, and we have a how high. Jaden, go for it. Good. So the 20 then is going to be this one over here, because that's going to be the ladder kind of laying up against the side. You could say, here's my ladder. I wouldn't draw this in, but that's the ladder kind of leaning up against the house. So you have a 20 there. My 5, where does my 5 go? Go for it, Kayla.
At the bottom.
Perfect. 5 goes at the bottom, because if this here's the side of my house, then it's 5 feet away from that house. And what we're trying to find is how high will the ladder reach. Does it make sense we're trying to find that then? Is that how high? That'd be the distance up the side of the house. So drawing that makes the problem a whole lot easier, because now we can ignore all that and just say we're finding X. So it's no longer a story problem. All right. I want to label A, B, and C. What has to be C? 20, X, or 5? 20. Perfect, because it's the hypotenuse, so this has to be C. A and B don't matter then, right? So maybe we'll have this side here, B. Osmond, what do you want it to be? A or B? A it is. So then B is down. Oh, B is the base. Convenient. So now we have A squared plus B squared equals C squared. Sure. And now that we label things, we can just put things in where they go. So X then is my A value. So A squared becomes an X squared once I replace A with an X. And my B value is 5, so I'm going to replace the B with a 5, so I get a 5 squared. And C is 20, so I have a 20 squared. You guys tracking with me still? And a good next step is just I messed up there. What did I screw up? Yep, it should be a 5 squared. I must have been saying 5 as I was writing the squared. So X squared plus 5 squared equals 20 squared. All right. A good next step is to just take care of those squares. So it's X squared plus 5 times 5 is 25. 20 squared, anybody do that in their head?
40.
Close. You square the 2 to get the 4, but then you double the number of zeros. So 400. So you square the first number and then just double the zeros if you're squaring something like that. All right. Next step in solving for X. Who sees it? Minus. Perfect. Perfect. Very nicely done, Jaden. So we have X squared equals 375. And now to get X by itself, we need to undo squaring. How do we undo squaring?
Square root.
Perfect. Square root. Nice, Kayla. And I heard some others in there too. So we just have to grab a calculator and say square root of 375. Sometimes people will leave their answer as square root of 375 because that's an exact answer. As soon as we punch it in, there's some rounding there. So this is going to be approximately, so maybe I'll even do the little squiggly equals, but X is going to be right around 19.36, you could say, feet. Or maybe 19.4 feet. I probably wouldn't round it down to 19. That's a pretty decent change. So 19.4, 19.36, something like that. I would encourage you to do all those steps. draw the triangle, then write out the a squared plus b squared equals c squared like I have in brown, then just fill stuff in. If you do the steps, it's going to be a lot more likely you'll get it right. You'll have the equation memorized by test time, and if I choose to collect your homework, you will get full credit. So.